Hi and welcome to another video of topic 3 geometry. Today we're going to be looking at the subsection 3.2 trig. This is for both SL and HL. So trig's made up of two main sections, triangles and circles. And so I'll first go through with you triangles. And so these formulas that I've put here, they're taken directly from the formula booklet and from IB. So you'll be having all of these formulas with you. And so to sort of clear up one, which is sine rule, you may be confused as to what A and what B and B represent. And so basically, in a triangle which you would draw, your uppercase letter will represent the angle in the triangle, whilst the lowercase letter will represent the length that you're trying to have. So hope that clears it up if you have any doubts. And so these are for your non-right angle triangles, these formulas. So looking at right angle, you should have known this from your previous learning circle as well. So sine is equal to your opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And so here's like a practice question, which I'll work with you to clear it up. So 8 squared, in this case you'd have to use cosine, which is above, so 8 squared equals to 10 squared plus 7 times cos x. So you get 64 equals to 100 plus 49 minus 140 cos x. And so 64 minus 149 minus 140 cos x. And so you'd get minus 85 equals to minus 140 cos x. And you'd have to divide both sides by minus 140. So the minus would cancel out, and you get 17 over 28 equals to cos x. And then you just have to find x equals to cos inverse, which would give you 52.6168. So I've worked out one of these for you. There's another two here, which if you want to do you can work out, but I'll move to circles now. And so these is like a diagram that I've drawn of what you have to remember in terms of arcs, as you already know that the area of a circle is equal to pi r squared, and perimeter is equal to 2 pi r. So these should be clear and you should know them from before. And so looking at arcs and sector, in this case, if you look at the sector here, L would be the sector in this case, while R both the radiuses, and this will be the angle theta, which you call it in degrees. And so to work out the arc length, it would be L, which is equal to theta over 360 times 2 pi r. As you're not trying to find an area, you're trying to find a length, you use a perimeter. And so if we're trying to work out the area of the sector, you do the same thing, theta over 360, but you'd multiply it by pi r squared. Another topic that should be clear on is minor and major arcs. So it's in the name of the words, but minor would be the smaller arc than the circle, whilst major would be the major arc. And so here's one practice question. If you want to pause, you can attempt it now, so I can work it out for you now. So it's similar to what we just worked out. So as you can see, this is a segment of a circle, so it's an arc. So these both will be equal. This will be 5 meters as well. So if you're trying to work out the area, it would be 220 over 360 times pi 5 squared. That would be what you have to do for the first part, and that'll give you 47, which you can round to 3 significant figures, which would just be 48.0. And now here, which I explained to you before, you need to work out this length. And so simply you'll have to do 220 over 360 times 2 times pi times 5, which will give you, which you can round to 3 significant figures as 119.2. And so now I've worked out a practice question here. I'm also going to work one here. This is an easy question. It's pretty similar to the one that I previously did, So you guys can attempt it and I can give you the answers now. So first you can look at the question. It says Mary M sits on the top of the eastern side. Below her stands point P, Peter. Is on the depth is 1,250 meters at this point. Nathan stands on the western side, which is a distance of 2.5 kilometers to Peter. And it says write down the depth of the Grand Canyon MP in kilometers. So this will just be 1,850, as it gives you. It is known that the depth is that. And it says for part B, on this diagram label the angle of elevation from N to M with an X. And so angle of elevation will always be going upwards. So you're trying to find the angle which is elevated at. This would be your X. And for C it says find the size of the angle of elevation from N to M. And so, sorry, before that I made a small mistake which I didn't really realize. It says here in kilometers. So this shouldn't be 1,850, it should be 1.85 kilometers. And so here it says work out the size of the angle. And so in this case you'd have to use tan, as you'd say tan x equals to 1,850 over 2,500, or 1.85 over 2.5. Whichever way you do it, you should get the same answer. So this we'll take this one. So x equals to tan inverse 1.85 over 2.5, which will give you 36.5 degrees. And so now for part D, it says work out the distance between Mary and Nathan. So you'll be working out this distance. As you know, triangle rules, Pythagoras theorem, it would just be, I'll take it as NM squared is equal to 2.5 squared plus 1.85 squared, and so NM will just be equal to the square root of, which will give you 3.11 kilometers. So hope this question is clear. If you have any doubts, you can put in the comments. And so as you can see, this mark is a bit longer. It's a 15 mark question, so it's always better to read through it first. So if you want to do it yourself, you can pause and do the question. So it says the quadrilateral represents a sports complex where AB is 210, BC is 90, CD is 130, and angle ABC is 70 and 5, and it's all given to you in the diagram. And for point A, it says find the length of the path A to C. And so in this case you'd have to use the cosine rule, as you've got one length and the other length and the subtended angle that it has. So in this case we can call this x, so it will be x squared equals to 210 squared plus minus 2 times 210 times 90 times cos 70. So using this you would get x approximately equals to 198 meters. So in the diagram we can label this as 198 meters. You can just put this into your calculator and it will give the answer. So for part B, show that the angle DAC is 39.4 degrees. So DAC will be this angle here. And so you have to show using sine rule. If we were to take this as, we can just take it as F. So you'd have to show F over sine F over 130 equals to sine 105 over 198. And so after you multiply with both sides and get the inverse, you would get F is equal to 35.6 approximately. So 3 significant figures is that what it asks for. And for C it says find the area of the sports complex. And so you have it here divided into two shapes. So you've got BCA and CDA. And so we can separate it here, BCA and CDA. And so you have to work out both of the areas using the half AB sine C. And so to get BCA, you would have to do half times 210 times 90 times sine 70. And you'd have to add this onto half of, which would be half times 198 times 130 times sine of ACD. If you realize here, this angle is missing. But it's pretty simple to find out the angle. I simply have to do 180 minus 105 plus 39.4. Which even if you mess it up before, you should be able to work it out as it gives it to you in the answer. And this would simply be 35.6. And so using that, you'd use it here, sine of 35.6. And so once you put this all into your calculator, you will get 16,400 meters squared approximately. And so for the D part, they ask for find the length of the path DE. As the previous states here, the new path DE is to build such that E is the point on AC closest to D. So the closest point that would be on AC would be here. I'll draw in a different color to make it clear. And so this would form perpendicular to here. And so it is asking for find the length of the path of DE. So we would use a thing which is called the sine ratio. So sine of 35.6, which is the angle of ACD, would be equal to DE over CD, which would mean that it would equal to sine 35.6 equals to DE over 130. And so DE would be equal to 75.7 meters approximately. And so for the last part, E, stated here, calculate the total length of the track. But before, it's important to read the section of the sports complex represented by the triangle CDE will be an outdoor running track A. A track will be marked along the sides of the section. Calculate the total length of the track. And so we can draw a triangle here just to make it more clear. And this would be C, this would be E, and this would be D. And so we've worked out DE is approximately 75.7 meters. And we know that CD is 130 meters. And we know that this angle is 35.6. And we know that this is 90. And so what we need to work out is C to E. And you know it's a right angle triangle. So you'd have to do x, you can call this x. So you can say x equals to the square root of 130 squared minus 75.7 squared. And doing that, we get CE is roughly equal to 106 meters. And so all you'd have to do is add these up together, 130 plus 106 meters, which would altogether give you 312 meters. So this is clear, and these are all the answers for that question. So now moving to a circles question, which is a bit harder. It's a 6 marker. Consider the shape below. The radius of the longer arc is 12 centimeters and the distance between the arcs is 3. Find the perimeter of the shape. So firstly, you'd have to break it down into two subsections. So you'd have the small arc and the bigger arc, as it has a larger radius. So if we were to work out the length of the small arc, it would be 70 over 360 times 2 times pi times 12. And so after you multiply that together, that will give you so to work out the length of the small arc, this is all 12. So to work out this, it would be 12 minus 3, which is equal to 9. And so what I have to do is 70 over 360 times 9 times pi times 2. And so this will give you 11 centimeters approximately. And so if you when you want to find the length of the large, it'd be the same angle, 70 over 360 times 12, as that's the total length, times pi times 2, which will give you 14.7. Again, approximately to 3 significant figures. And so the total perimeter of the shape will be 11 plus 14.7 plus 2 times it by 3, as you only need to look for the shaded region as you're calculating this and this and that and that. And so this will give you together 31.7 centimeters. And so for part B, to find the area of the shape, you have to subtract the area of the small sector from the big sector. So we can use the area of the sector formula, which you know is theta over 360 times pi r squared. And so to work out the area of the larger shape, it would be 70 over 360 times pi times 12 squared, which gives you approximately 87.96 centimeters squared. And so to work out, then we have to also work out the area of the small, which should be the same, 70 over 360 pi times squared, which will give you approximately 49.48. And so now to work out the area of the shaded, it'll simply just be 87.96 minus 49.48, which will give you 38.5 centimeters squared. So that'll be it for the video. If you have any questions on the question that I put here, just leave them in the comment section. I'll be responding. Thank you.